All right, so here is the last part of lesson 14, and this is the part where we just kind of review and go over all the things we've learned as far as adding and subtracting word problems using fractions, mixed numbers, and decimals. So let's do a warm-up. For this one, we're given a scenario where we're going to have to estimate and then do the actual answer. So Arnetta reads her book for 1 3/4 hours. Then she goes to a soccer practice for 1 1/3 hours. How much time does she spend on these two activities? So estimate and solve. Tell if your answer is reasonable. Well, estimating just means we're going to have to take these numbers. So this is when she was reading, and this is when she was at soccer practice. I'm going to round these hours to the nearest hour, just so I get a general idea of how long it was. If I'm 1 3/4 hours, that lets me know I'm closer to like 2 hours for that. 1 1/3 hours, I'm not even like half an hour past 1 hour, so I'll keep that at 1. So 2 + 1 is 3 hours. So that's what we're looking at for there. To do the actual math for it, again, we take our two mixed numbers, 1 3/4 plus 1 1/3. And we have to find that common denominator. With 4 and 3, I can't change the 3 into the 4. So I'll do 3 times 4, and that gives me a common denominator of 12. So this will give me 1 something over 12, and the same over on this side. 4 times 3 is 12. 3 times 3 is 9. 3 times 4 is 12. 1 times 4 is 4. So we have 1 9/12 plus 1 4/12. We add up our whole numbers, that's 2. We add up our decimals, or excuse me, fractions. 9/12 plus 4/12 is 13/12. And your answer could be 2 13/12, but you see that you have more than a whole. So a whole would be 12/12. So we could take that away and give us 3 1/12 hours. So they're super close. And in real life, a lot of people, if they've got times like this, they just round up and get a general idea for how many hours they spent doing something. Some people want to be more precise, but a lot of times we just keep it general. So that's a good warm up for that. All right, let's get into it. It's page 287. And at the top of page 287 is an example that's already solved for you. So we're just going to jump right to question 1. We're not going to do all of these. We'll just do some of these. So Parker mixes 3.5 ounces of blue paint with 1 2/5 ounces of yellow to make green paint for the leaves of a tree. How many ounces of green paint did Parker make? So we are given, we're going to assume he mixed all of the paint he had here. So we've got our blue and our yellow. And since we're mixing, we're basically adding things up. So we're going to add. Estimate and then compute. That doesn't mean act like a computer. That just means find the actual answer. So let's do the estimate on the left and the actual answer on the right, just how we've been doing. So I've got 3.5 ounces plus 1 2/5 ounces. Here's what we could do. We could do it like this. You could just do it real simple. You could take that 3.5 and round it up to 4. That 1 2/5, since it's not quite 1.5, we could just round that to 1. And that gives us 5 ounces, or 5 OZ. So that's a good way to do that one. The actual is if we took 3.5, added 1 2/5, and I'm looking at my denominators, as always, 2 and a 5. And I know my common denominator will likely just be a 10. Okay, so you've got 1 and something over 10. And this is 3 and something over 10. Let's see what we have here. 5 times 2 is 10. 2 times 2 is 4. 2 times 5 is 10. 1 times 5 is that. So 3 and 5/10 plus 1 and 4/10 equals 3 plus 1 is 4. 5/10 plus 4/10 gives us 9/10. And we're just 1/10 away, 1/10 ounces. We're only 1/10 away from 5 ounces, so that's very reasonable because they're the actual and the estimate were super close. There we go. Let's look at, let's do number 2. For this here, because it looks like I'm going to do an estimate and an actual again. In fact, let me just write this out. But again, with this, if you look at these numbers, you notice we're now dealing with decimals and not fractions or mixed numbers. They're all, like I said, related to one another. They could be easily converted to one another, but we're just going to stay consistent. Jamie's football has a mass of 0.435 kilograms or 435 thousandths kilograms. His football helmet has a mass of 2.57 kilograms or 2 and 57 hundredths kilograms. Estimate how much more the mass of the helmet is than the mass of the football. So first things first is we're dealing with the football, which has this mass, so we're going to circle that. And the helmet, which we'll just continue over here. And we want to, this phrase right here, how much more, means you want to compare them and find a difference. So we're going to subtract. Again, it's all in how they word the problems to tell you what type of math to do. So let's estimate, instead of rounding to a whole number, I'm going to do this because, again, with estimating, you can do it any way you'd like as long as it makes the numbers easy to work with. So see the mass of the football helmet is 2.57. I'm going to go with 2.5. And then the football is 0.435. That's awfully close to just 0.5. So if I have 2.5 minus 0.5, that's going to give me 2.0 kg for kilograms. So let's see how close we actually are. For actual, you have to use the numbers that are presented to you, no changing anything. 2.57 minus, and again, I put my decimal point first to make sure I line up my numbers properly. So this is 0.435. I've got this space right above this 5 that I can fill in with a 0 to kind of help guide me on that. Okay. All right, then we do our math. So bigger bottom, better borrow. So we can borrow from, let me do this in red. Borrow from over here, we'll take a whole number, and that becomes that. So 10 minus 5 is 5, 6 minus 3 is 3, 5 minus 4 is 1. Bring down your decimal, and bring down your 2. And the actual answer is 2 and 135 thousandths kilograms. That's sure close to 2, because at least there's that, and then our decimal part of that is very, very small. So they're super close. All right. Next one, skip 3, skip 4, and let's do number 5. And again, we're going to do an estimate and then an actual. And then we have one more after this, and then we'll be all done. Okay. Carter is at the school store. He wants to buy a pack of notebooks that cost $4.79, a calculator that costs $33.54, and a tablet case that costs $12.67. So pack of notebooks, calculator, and tablet case. So that, again, I circle things to draw our eyes to it, and also kind of a mental check to make sure I'm using all the numbers provided. Sometimes the numbers get lost in the sea of words here. About how much money does Carter plan to spend at the school store? So if you take all your stuff up to the cash register at a store, they add it all up. So we're going to add up all of these. All right, so let's take these prices. Let's see, calculators, $33.54. I'm going to round that up to $34. The notebooks or the tablet case is $12.67. I'm going to say $13. I'll round up to the nearest dollar. And $4.79, let's say that's $5. Again, even if I was in real life in a store, I would be rounding my numbers up. And it's always better when you're dealing with money, prices, to estimate big, because it'd be better to go a little over in your head with your mental math than coming up short when you walk up to the cash register and you don't have quite enough money to get all the stuff you need. Zeros are easy to add. 5 plus 3 is 8. 8 plus 4 is 12. 3, 4, 5. So we're looking to spend about $52. That's our estimate, $52. So let's find the actual. So it's $33.54. And let's go with the notebooks. Again, order doesn't matter with adding. I could have used any of these in any order, and I'm still going to end up with the same answer. 9 plus 4 is 13. 7 plus 5 is 12. Plus 1 is 13 again. 4 plus 3 is 7. Plus 1 is 8. Plus 3. So I have $38.33, but we can't forget our case. That's $12.67. 7 plus 3 is 10. 6 plus 3 is 9. Plus 1 is another 10. 8 plus 2 is 10. Plus 1 is 11. 3, 4, 5. And the actual cost is $51. So that's a good thing. Our estimate was a little high by $1. So that would have made sure that we at least went up there with the right amount of cash to get our stuff. In fact, we'll have $1 left over in change. So again, when you're dealing with money, whether purchasing items or food, always estimate big. Okay. Oh, and that statement about always estimate big, that actually answers this question right here. I kind of just answered it indirectly. The actual cost was a little lower because our estimates were all bigger. And I planned on skipping 6, and then let's do 7. And this is a quick one. So Ramona has 4 1/5 gallons of red paint. She knows she needs at least 12 3/4 gallons to paint her whole house. Let's see, we have a very small house. Uses benchmark fractions to explain about how much more paint Ramona needs. So what we have here is she has that 4 1/5 gallon of red, but she knows she needs at least that much. So we want to find the difference. If she needs 12 3/4 and she goes to the store, she won't need to buy 12 3/4 worth of paint because she already has some. So let's find the difference. It says to use benchmarks. So benchmarks are, remember, quarter, halves, and 3/4. Those you want to, especially with your mixed numbers. So let's go with 12 3/4. And at 4 1/5, let's change it to 4 1/4. 12 minus 4 is 8. And then 3/4 minus 1/4. Since the 3/4 is bigger, we won't have to actually do any borrowing. That gives us 8 2/4. Or if you really want to, you can just reduce that to 8 1/2. So there's that. And that's it. That's it for doing that. It's actually our last lesson we're going to do for this book. And your homework for today is L18, estimate sums and differences of mixed numbers. Yesterday's we've already dealt with decimals, so today I thought it'd be mixed numbers. Using those benchmarks, using the idea of rounding up, you can use to do your numbers for that. It's going to be adding and subtracting. And if you have any problems, just let me know and I will help you get that done.